So we are in permutation, and at the last we had discussed the definition of a disjoint cycle. So we know what is a cycle. So let us start with an example of a cycle, or let us see whether the given permutation is a cycle or not. So let me consider, let's say sigma is equal to 1 2 3 4 5 6. So it is an element of S6. So let us consider it is 1 2 3 and say 4 5 6. So how can I write it is, so here one image of 1 is 4, so I will write 4 on the right hand side of 1. So 1 goes to 4, then 4 goes to 2, 2 goes to 3, and 3 goes to 1. So we arrived at the element from where we had started. So we stop here. So now 1 2 3 4. Now the remaining objects or remaining elements are 5 and 6, but 5 goes to 5, 6 goes to 6, so they are invariant. So this is what sigma is, a 4 cycle or a cycle of length 4. So what do you mean by the cycle, right? Okay, so now let us discuss further things in this permutation. So obviously, what is identity element? What is identity element in Sn? See, if you consider S4 or S3, S2, whatever, to understand we consider S4. So what is the identity element in S4? Then it is what? So we know that identity element is what? 1 2 3 4, a function or a permutation in which every elements are invariant. So 1 goes to 1, 2 goes to 2, 3 goes to 3, 4 goes to 4. So this is identity in S4. So whether it is a cycle or not, so let us see. So you start with 1. So 1 goes to 1. So stop. हम जहाँ से start करते हैं वहीं पे आ जाए, then we stop. So 1 goes to 1 and the remaining element should be as it is. So it is what? Remaining elements are 2 goes to 2, 3 goes to 3, and 4 goes to 4 by definition of identity. So we will not write the remaining one. So this I is what? I is a cycle, but it is what? It is a cycle of length 1. Cycle of length 1, or we may say it is a one cycle, or it is a one cycle. So if I consider here S5, then I have 5 goes to 5, and we have the same thing, right? So in Sn, identity element is a cycle of length 1. Okay, or I can write in this way also. Let me start with 2. So 2 goes to 2, so stop. And the remaining element other than 2's, that is 1, 3 and 4, it should be invariant, and they are invariant, right? So I can write I in this way also. I can write similarly, I can write I in this way also. I in this way also. So I can write identity element in so many ways, right? And it is what? Cycle of length 1. This is also cycle of length 1, cycle of length 1, and cycle of length 1. So let us write some results and properties. Results and properties. So first one, the identity element, the identity element in Sn is a cycle of length 1. And moreover, or also if I is identity, then I can be written as 1, or you may say 2 or 3 and so on in this way. So you can write identity in this way also, right? So this is my first result about this cycle. Now let me consider one cycle. Let say sigma is equal to 3 goes to 4 goes to 2 goes to 5, and this is say element of S7, right? So what does it mean? Image of 3 is 4, image of 4 is 2, image of 2 is 5, and image of 5 is 3, and the objects other than this 3, 4, 2, 5, so there are remaining 3 objects, that is 1, then 6 and 7. So they are invariant under this sigma. Okay, so if I write this thing in this way, what happened? Let us see. Let me write first 4, then 2, then 5, and then 3. So this is also a cycle of S7. Okay, first let me write sigma. Sigma is what? 1, 2, 3, 4, 5, 6 and 7. Image of 3 is 4, image of 4 is 2, image of 2 is 5, and image of 5 is 3. And remaining are 1, 6 and 7 as it is. These 3 are as it is. So let me highlight in this way. 1, 1. So 1, 6 and 7 are invariant. Okay. And what this represent, this cycle? Image of 4 is 2, yes. Image of 2 is 5, yes. Image of 5 is 3, yes. And image of 3 is 4, yes. So this cycle also represents the same permutation. So this is also sigma. So what I did here, I changed the order of these elements, but in a particular manner. What I did, I have considered 4 here, 4 on the first, then 2, then 5 and then 3, right? So, okay, let me consider in this way: 2, 5, 3 and then 4, right? So what this is also a cycle of S7, and what it represents: image of 2 is 5, image of 5 is 3, image of 3 is 4, and image of 4 is 2, and remaining are as it is. So again this represents the same sigma. Let me write in this way also: 5, 3, 4, 2. So again you can say this will represent the same sigma. So this is also a cycle, right? Okay, if I consider again 3, 4, 2, 5, then I get this same one. So see, here sigma is a cycle of length 4. In the first presentation, 3 is on the first position. Then I rewrite this sigma in which 4 is on the first position, then 2 is on the first position, and then 5 is on the first position, and the remaining elements are in the cyclic order. I do not have changed the order of this cyclic order of these elements. See, if I consider in this way: 4, then 2, then 3 and 5. Let me consider in this way. So what it represent? So this is what? 1, 2, 3, 4, 5, 6, 7. Image of 4 is 2, image of 2 is 3, image of 3 is 5, and image of 5 is 4, and images of 1, 6, 7 are as it is. So 1, 6 and 7. So now you compare these two. So here image of 2 is 5 and here image of 2 is 3. So these two are not equal. Here the Elements in the cycle, objects in the cycle are the same one, but they are not in the its cyclic order are not same, right? After 2 I have 5, so wherever I write 2, then immediately its image will be 5 in any of this. 2 then 5, 2 then 5, here 2, then if 2 is on at the end, then means first element, so 2 then 5, but here 2 then 3. So other elements order also changed here. So what does it mean? The cycle does not change by changing the order of its element in cyclic order, right? So let us put these things in remark. So a remark or result. So the second one, a cycle does not change. A cycle does not change by changing the places, by changing the places of its elements in cyclic order. Of its elements, provided its cyclic order does not change. Its cyclic order is not changed. You can write in this way also. So a cycle does not change by changing the place of its elements, provided its cyclic order is not changed. Okay, so now suppose I have given a S7. You look at S7. Now I want to count how many cycles of order 4, or not order 4, but let me say it's 4 cycle or cycle of length 4, कि S7 में 4 लेंथ के कितने साइकिल है. एक्चुअली S7 में एलिमेंट कितने है 507 फैक्टोरियल. 7 फैक्टोरियल इज 5040, राइट. 5040 एलिमेंट्स है, तो उसमें से 4 लेंथ के साइकिल कितने हैं, तो क्या होगा, मुझे 4 लेंथ के साइकिल चाहिए. तो S7 मीन्स व्हाट, S7 में क्या होगा, it is a permutation. Permutation means it is a function, and it is a function from where to where, 1 2 3 4 5 6 7 to 1 2 3 4 5 6 7, or 7 object to 7 object the same set. तो मुझे 4 लेंथ के साइकिल चाहिए, तो क्या करना पड़ेगा, आई हैव टू सिलेक्ट एनी 4 एलिमेंट्स, उसमें से 4 एलिमेंट डिस्टिंक्ट ले लो, देन यू कंसिडर इट्स अरेंजमेंट. सो हाउ मेनी वे आई कैन डू इट, it is 7p4. You consider 4 elements or 4 objects out of 7 objects and you arrange in a row, then you will get a cycle. But from this observation, what we have the information, that if you consider this out of 7, you choose these 4 elements 3 4 2 and 5 and you arrange in a row. So in this number, so what will be this, it is 7 factorial divided by 7 minus 4 factorial, that is 7 factorial divided by 3 factorial, whatever this number is. We are not interested in that number right now, but 7p4. So in this number, these 4 cycles are counted distinct, लेकिन हमें ये पता है कि ये तो सेम है, राइट, these 4 are same. So I have to divide this quantity by 4. So this divided by 4, this divided by 4, and this divided by 4. So this is what? This is total number of 4 cycles in S7. तो S7 में कितने 4 साइकिल कितने हैं, देन दिस इज व्हाट काउंटिंग ऑफ 4 साइकिल्स इन S7। तो पहले हमने क्या किया, 4 साइकिल बनता कैसे है, उसमें 4 ऑब्जेक्ट आते हैं, डिस्टिंक्ट 4 ऑब्जेक्ट्स। सो यू choose 4 objects out of 7 objects and then you arrange it, so that is 7p4. See, if you choose just, then it is 7c4, but we are interested not only choosing, but we have to arrange it in a row, so that can be done by 7p4 ways. But out of this 7p4 ways, these 4 are counted distinct, but we know that as a cycle these are same. So we have to count all this as a one cycle. So every cycle it has 4 copies. So you divide it by 4. So finally whatever the figure is, your answer. So if we try to compute it, then it is what? This will be 7 into 6 into 5 into 4 into 3 factorial will cancel out and divide by 4. So again 4 cancel. So it is 7 into 30 and 210. So there are 210 cycles of length 4 or 4 cycles in S7. Okay, so in general total number of R cycle, here 4 cycles, so total number of R cycle in Sn is what? It is NPR divided by R. So let me write that third. So total number of R cycle in Sn is equal to NPR divided by R. That is what? It is n factorial divided by NPR. So it is n minus R factorial and into R, this R. So this is what total number of R cycles in Sn. Now we know what is a disjoint cycle, right? So you consider let F is equal to 2, 3, 5 belongs to say S8 and G is equal to 1, 4, 7 1, 4, 7 and 3, 6. Okay, fine. 1, 4, 7 belongs to S8. You consider these 2 cycles. Then F and G are disjoint cycles. Then F and G are disjoint cycles. So let us find out FG. So FG is what? 1, 2, 3, 4, 5, 6, 7, 8. And G is 1, 2, 3, 4, 5, 6, 7 and 8. Then 2 goes to 3, 3 goes to 5 and 5 goes to 2. And the remaining are as it is, 1, 4, 6, 7, 8. So these are as it is, right? Okay, fine. Here 1 goes to 4, 4 goes to 7 and 7 goes to 1. And the remaining 2, 3, 5, 6 and 8 are as it is. Now let us compute this product. And as we had decided, we will always compute from left to right. So it is 1, 2, 3, 4, 5, 6, 7 and 8. 1 goes to 1, 1 goes to 4. Right? 1 goes to 1, 1 goes to 4. तो देखिए इसमें क्या हुआ कि यहाँ पर F में 1 नहीं था, 1 is not there. तो मतलब 1 वो F क्या कर रहा है, 1 goes to 1. So 1 is invariant under F because 1 is not here. But here 1 goes to 4. So ultimately 1 goes to 4. Now 2 goes to 3. 2 goes to 3 and 3 goes to 3. So here see, 2 is present, so 2 goes to 3, and here 3 is absent, so 3 goes to 3 in G. So 2 goes to 3. So ultimately see, here 1 is present in G. So whatever the image of 1 will be, that is due to G only ना. तो G में 1 की इमेज क्या है 4, तो यहाँ पर 1 की इमेज मुझे FG में 1 की इमेज मिल गई 4. एंड हियर 3 इज नॉट प्रेजेंट इन G बट 3 इज प्रेजेंट इन F, राइट. तो 3 की इमेज क्या रहेगी FG में, सॉरी 2 की इमेज, नॉट 3 बट सॉरी 2 इज प्रेजेंट इन F बट नॉट इन G. तो 2 की इमेज FG में क्या रहेगी, दैट इज ड्यू टू F ओनली, राइट. तो F में 2 की इमेज क्या है 3, तो FG में भी 2 की इमेज क्या रहेगी 3. Okay, now let us find some element which is not in F and not in G. So for example, 1 2 3 4 5 6 is not in F and 6 is not in G also. So what will be the image of 6? We can find from here, but let us find in this way. 6 does not change by F, it is invariant, and 6 does not change by G, so 6 will not be changed by F and G both, right. Here 6 goes to 6 and here also 6 goes to 6. So if you go in from F to G or G to F, in both the case 6 goes to 6, so 6 goes to 6, right. Now similarly, what is the next remaining? 8. So 8 is not here, 8 is not here, so 8 goes to 8, 8 goes to 8, so 8 will be 8. And let us verify. Here 6 goes to 6, 6 goes to 6, 8 goes to 8, 8 goes to 8. Now what about 3 4 5? So where is 3? 3 is in F, so 3 goes to 5, so I will directly write here 3 goes to 5, and you can verify also. 3 goes to 5 and 5 goes to 5, so it is 5. Now 4, I want to find the image of 4. 4 is where? It is in G, so 4 goes to 7, so I will just write 4 goes to 7. And let us verify. 4 goes to 4 and 4 goes to 7, so 7. And what about 5? 5 is here only, so 5 goes to 2, so 5 goes to 2. And let us verify. 5 goes to 2 and 2 goes to 2. What about 7? 7 is here. 7 goes to 1, so 7 goes to 1. And verify. 7 goes to 7 and 7 goes to 1. So we can do this thing only when we have two disjoint cycles, right. तो मतलब कि ये 2 3 5 में जो भी चेंज आएगा दैट इज ड्यू टू F ओनली, एंड 1 4 7 में जो भी चेंजेस है दैट इज दैट परम्यूट्स ड्यू टू G ओनली, एंड द एलिमेंट्स विच आर नॉट इन F एंड G remains invariant, right. So if you find GF, right, then it is 1 2 3 4 5 6 7 8, and let us without writing these two expression, let us find GF. तो GF में क्या रहेगा, तो G में कौन कौन से परमिट हो रहे हैं? 1 4 7, 1 goes to 4, 4 goes to 7 and 7 goes to 1. And F में 2 goes to 3, 3 goes to 5 and 5 goes to 2. 6 and 8 are not in F and G, so they will be invariant. But these two things are same. So what we have? FG is equal to GF. So this thing happen only when two F and G are cycles and they are disjoint cycles, right. तो इससे क्या हमें रिजल्ट मिलता है? So the next result is this one. If F and G are disjoint cycles, then FG is equal to GF. That is, disjoint cycles can commute. कोई भी दो परम्यूटेशन ले लिए आपने, then they will not commute. कोई भी दो साइकिल ले लिए, then you can't say that they commute. But if you have two cycle and they are disjoint, this word is very important. Disjoint. F and G are disjoint cycles, then you have the guarantee that they are commute. Okay. और एक चीज़ हमें और एक सीखनी है कि अभी देखिए हमें एफ जी कंप्यूट करना था, तो हमने एफ को इस तरह से लिखा, जी को हमने ऐसे लिखा, देन वी कंप्यूट इट, लेकिन अब मेरे पास एफ और जी साइकिल के फॉर्म में है, तो मुझे ऐसे लिखने की ज़रूरत नहीं है. वी कैन कंप्यूट डायरेक्टली. सो हाउ वी कैन कंप्यूट डायरेक्टली, लेट अस सी. Let me, this is my fg, right? This is my fg, both are same, so this is my fg. So let me keep this for record only, and let us see how can we compute without expressing in this larger form. See, let me write here f 2, 3 and 5 and 1, 4 and 7. तो इसका मतलब हमारा उससे ही है, वो बड़े वाले फॉर्म से, लेकिन वो हम लिख नहीं रहे. सो हाउ वी कंप्यूट इट? सी, लेट अस कंप्यूट इन दिस वे. यू स्टार्ट विथ एनी सिंबल. वी नो वी आर वर्किंग इन S8, so you can start with 1, 2, 3, 4, 5, 6, 7, 8, whatever you like. There is no any restriction. But let me start with 2. यहाँ पर 2 है, then let me start with 2. Or you can start with 1 also, doesn't matter. Let us start with 1. So let me start with 1. तो यहाँ पर देखो, you start with 1. What is the 1? What is the image of 1 in this? Here 1 is not present. It means what? 1 is invariant under this cycle or whatever this permutation. So 1 goes to 1. Now you look at the image of 1 goes to 1. So now you look at the image of 1 here. So 1 goes to 4. So 1 goes to 4. Now you look at 4. What is the image of 4 in first cycle? 4 is not here. So 4 goes to 4. So 4 goes to 7. Now you look at the image of 7 here. 7 is absent. So 7 goes to 7. And here 7 goes to 1. Right? बट हमने जहाँ से स्टार्ट किया था वही आ गया. देन वी स्टॉप हियर, राइट? नाउ व्हाट इज नेक्स्ट? नेक्स्ट इज whatever the missing object here, you start with that object. So here 1, then 2 is not here, so let me start with 2 here. 2 goes to 3 and here 3 goes to 3. So 3. Now 3 goes to 5. 5 goes to 5. 5 goes to 2 and 2 goes to 2. So as it is. Right? Okay. And 5. Then 5 goes to 2 and 2 goes to 2. So okay, we arrived at the starting point. So finish. Now you start with the object which are not present in this 2. So it will be what? 1, 2, 3, 4, 5, 6 is not there, right? So you start with 6. 6 goes to 6. 6 goes to 6. So stop. Now the remaining next object is we are working in 8. So 8 is missing now. So 8 goes to 8. 8 goes to 8. So we have this. But these two things represents the identity as we noted in the first remark. So no need to write these two things. So we can write this 1, 4, 7, 2, 3, 5 only. So it is we can omit this 6 and 8 because they represent the identity. So f and g is what? Is a product of two cycles. तो हमें यहाँ और कुछ नहीं मिला, जस्ट इसका ऑर्डर चेंज हो गया. देखिए, सो व्हाई इट हैपन? बिकॉज दे आर डिसजॉइंट साइकिल. यदि मेरे पास कोई साइकिल डिसजॉइंट नहीं है, देन आई कैन फाइंड प्रोडक्ट डायरेक्टली. लेट अस कंसिडर द नेक्स्ट एग्जांपल. यहाँ पर हमारे पास क्या हो गया? बाई चांस ये दोनों डिसजॉइंट साइकिल आ गए थे, लेकिन हमारा पर्पस क्या है कि मुझे कोई दो साइकिल दिए है, वो वॉट एवर, तो मुझे उसका प्रोडक्ट फाइंड करना है. तो उसको मुझे वो 2/n मैट्रिक्स फॉर्म है उसमें लिखने के बजाय डायरेक्ट प्रोडक्ट फाइंड करना है. तो कैसे फाइंड करना है? सो दैट इज आवर पर्पस. सो लेट अस do this thing with so you consider say f is equal to 1, 5, 3, 2, 6 belongs to say S8 or let us consider S7 only now. G is equal to 2 3 2 3 7 5 1. Okay, right? So this is also element of S7. Now I want to find F into G. So here you can see here F and G are not distinct because 1 is repeated, 2 3 5 and okay, 6 is not here, 7 is not here. Okay, that's fine, but these two are not disjoint. Now I want to find F into G. So one way is what? One way is this one. Let us consider in that way first. 1 2 3 4 5 6 and 7. 1 2 3 4 5 6 and 7. From here F is what? 1 goes to 5, 5 goes to 3, 3 goes to 2, 2 goes to 6 and 6 goes to 1. 4 and 7 are invariant. And G, 2 goes to 3, 3 goes to 7, 7 goes to 5, 5 goes to 1 and 1 goes to 2. 4 and 6 are invariant, and let us find out this. 1 2 3 4 5 6 and 7. So 1 goes to 5, 5 goes to 1. 2 goes to 6, 6 goes to 6. 3 goes to 2, 2 goes to 3. 4 goes to 4, 4 goes to 4. 5 goes to 3, 3 goes to 7. Okay, 5 goes to 3, 3 goes to 7. Sorry, what I did here, let me start compute from the beginning. Okay, for 1 goes to 5, 5 goes to 1. 2 goes to 6, 6 goes to 6. 3 goes to 2, 2 goes to 3. Now for 4, 4 goes to 4, 4 goes to 4. For 5, 5 goes to 3, 3 goes to 7. For 6, 6 goes to 1, 1 goes to 2. And for 7, 7 goes to 7 and 7 goes to 5. And let us verify 1, 2, 3, 4, 5, 6 and 7. Yes. So we have this F into G. But now the second way is what? Second way is this one. F into G is what? 1 5 3 2 6 and 2 3 7 6 1. So we start F and G in this form only, in the cycle notation only, and you start with 1 2 whatever you like. So let me start with 1. So from here 1 goes to 5 and here 5 goes to, so you find out the image of 1 in the first cycle, then whatever you get the image, you find out image obtained in first cycle in the second cycle. So here image of 1 is 5, and now you look at what is the image of 5 here. So 5 is absent, so 5 goes to 5, so I will write here 5. Now you look at the image of 5 in this cycle, 5 goes to 3. Now you look at the image of 3 in this cycle, 3 goes to 7, right? Now you look at the image of 7 in first cycle, 7 goes to, 7 is absent, so 7 goes to 7, here 7 goes to 6, so you write 6. Now 6, look at the image of 6 in first cycle, 6 goes to 1 and here 1 goes to 2, right? Now 2 goes to 6, 6 goes to 1, 6 goes to 1, so 2 goes to 1, but 1 is what? It is a starting point, so 1. We stop here. Okay, now 1 2 1 2 3, 3 is absent, so you start with the object which is absent here. So here I have 3. So from here 3 goes to 2 and here 2 goes to 3, so stop. Right? Now 1 2 3 4 is missing, so you start with 4. Here 4 is absent, so 4 goes to 4, 4 goes to 4, so stop. Right? Now what is missing? 1 2 3 4 5 6, and we are 6 and 7. So we are working in S7 and all 7 objects are occurred. So we stop here. But we know that 3 and 4 represents what? It represents the identity. So no need to write this thing. So it is simply 1, 5, 7, 6 and 2. You can omit this because it represents the identity. Ultimately this is what? This is an element of S7. This is element of S7, element of S7, but it represents the identity. Say this is you compare like this, A identity into identity, and we are in group. So identity into identity is identity, A into identity is A. So no need to write this identity in short. Okay, fine. Now let us write down this in that matrix notation. That is 1, 2, 3, 4, 5, 6 and 7. Image of 1 is 5. Image of 5 is 7. 5 goes to 7. Now 7 goes to 6. 6 goes to 2 and 2 goes to 1, and 3 and 4 are invariant. Now you compare these two things. 1, 6, 3. Why it is different? We did some mistake, please. 1 goes to 5, 5 goes to 7, 7 goes to 6, 1 goes to 5, 5 goes to 7, 7 goes to 6, 6 goes to 2 and 2 goes to 1. I think 1, 5, 3, 2, 6, 1, 5, 3, 2, 6, 2, 3, 7, okay. 2, 3, 7, 5, 1 and I written here 6. So that is a mistake. So let us change it. So let me consider this is 5 and let me recompute this. Then say 1 goes to, okay. So let me rewrite again. This is what? Fine, okay. Let me consider in this way. This is 6. Let me consider this 6 and G is what? 6 goes to 2 goes to 3, 3 goes to 7, 7 goes to 6 and 6 goes to 1 and 1 goes to 2. That is fine. So this 5 is missing, right? So 5 as it is. 1, 2, 3, 4 goes to 4, 5 goes to 5. Okay. And now let me recompute this one. 1 goes to 5, 5 goes to 4, 5. So this will be 5. 1 goes to 5 and 5 goes to 5. Now 2 goes to 6, 6 goes to 1. 3 goes to 2, 2 goes to 3. 4 goes to 4, 4 goes to 4. 5 goes to 3, 3 goes to 7. 6 goes to 1, 1 goes to 2. 7 goes to 7, 7 goes to 6. So I have this thing. Now let us see what happened here. So here it is what? You start with 1. So 1 goes to 5, 5 goes to 5. 5 goes to 3, 3 goes to 7. 7 goes to 7, 7 is missing here. So 7 goes to 7, 7 goes to 6. 6 goes to 1. Now you find the image of 6 in the first cycle, that is 6 goes to 1 and 1 goes to 2. Now 2 goes to 6 and 6 goes to 1, but 1 is starting element, so we stop here. So stop. Now you start with any element which is missing here. So if you go in the order, then 1, 2, 3 is missing, so you start with 3. 3 goes to 2, here 2 goes to 3, so stop. Now 1, 2, 3, 4 is missing, so you start with 4. Here 4 is missing, so 4 goes to 4, 4 goes to 4, so stop. Now 1, 2, 3, 4, 5, 6, 7, and this represents the identity element. So 1, 5, 7, 6, 2, and if you rewrite in this way 1, 2, 3, 4, 5, 6 and 7, then here 1 goes to 5, 5 goes to 7, 7 goes to 6, 6 goes to 2 and 2 goes to 1 and 3 and 4 as it is. And now you compare these two things, 5 1 3, 4 7 2 and 6, right? So this is the another way to compute the product of f and g without writing in this matrix notation, right? So what we are doing, you start with any object. Here I have started with 1, but you can start with 2 also, 3 also, 4 also, whatever you like, right? And you find out the image of that in the first cycle. Whatever you get the image, you find out the image of that image in the second cycle, and whatever the image you write down next to it. And suppose if you have your third cycle, then you carry that image and find out the image of that image in the third one, and you can do in this way, right? Okay, यहाँ मैंने पहले start किया था 1 से. You can start with any object, right? So let me illustrate with other object. So let us say fg is what? 1 5 3 2 6, 2 3 7 6 and 1. Okay, let me start it with say 5 or 3. Let me start with 3. You can start with any object. Here I had started with 1. Let me start with 3. So what is 3 goes to what? You find out the image of 3 in first cycle. 3 goes to 2. Then 2 goes to 3. So stop. Right? Okay. Now you can start with any object. You can start with any object which is missing here. Here 3. Then what is the missing out of 7? 5 is missing. So let me start with 5 also. You can start with 5 also. So 5. Then 5 goes to 3, and here 3 goes to 7. Here 7 goes to 7. Here 7 goes to 6. 6 goes to 1, and here 1 goes to 2. 2 goes to 6, and here 6 goes to 1. Now 1 goes to 5, and here 5 goes to 5. So 5. So we had started with 5. So you stop. Now you can start with any object which is missing here. So 1 2 3 4 is missing. So 4 goes to 4. 4 goes to 4. So stop. Now 1 2 3 4 5 6 7. All objects are covered. And here 3 and 4 represents the identity, so no need to write this 3 and 4, so it is just 5 7 6 2 and 1. And here also we get 3 4. See, you can compare. Here 3 4 at last, but here 3 and 4 are at the beginning and at end. But what is the represent of this one? Image of 5 is 7, image of 7 is 6, image of 6 is 2, image of 2 is 1, and image of 1 is 5. And the remaining are as it is. So this represents the same one. Or you may see in this way also. See, here first is on the first position now. So you just write down 1 on first. Then what is the image of 1? Image of 1 is 5. So you just rewrite this cycle without changing the cyclic order of the element. 1 then 5. 5 then 7, 7 then 6, and 6 then 2, and 2 then 1, but 1 is already here. So by first remark, by the second remark, these two are equal now, because we are not changing its cyclic order. So in this way we can compute. लेकिन ये compute करने का फायदा क्या है? What is the benefit? Very soon we will see, but let us if we have this calculation on the board, then let us discuss it. देखिए fg ये मेरा कोई permutation है, right? This is what? This is my permutation. तो इसको मैं कैसे लिख सका? In this way. If you forget this, then it is in this way. So this is what? This is a cycle. This is a cycle, and this is also a cycle. यहाँ पे 3 4 के बजाय कुछ और भी हो सकता था. ये permutation कुछ और है तो. So this is what? It's the product of cycle. It is a product of cycle, and whatever the object is here, it is missing here. Whatever the object here, it is missing here and here. Whatever the objects are here, they are not here and here. So they are product of disjoint cycles. So we'll see that results, and that is a very important result. Okay, but before that, we so this is what our two disjoint cycles are commute. Okay, now we also know how to find the inverse. इनवर्स कैसे निकालना वो भी हमें पता है, राइट. सो लेट अस फाइंड आउट द इनवर्स ऑफ ट्रांसपोजिशन. ट्रांसपोजिशन का इनवर्स क्या हो सकता है? सी यू कंसिडर tau is equal to transposition means what? It is the cycle of length 2. So you consider tau is equal to 3, 4, belongs to S4. So this is what it is, a transposition, right? So I want to find the inverse. तो क्या होगा? So this tau is what? If you actually write 1, 2, 3, 4, then 3 goes to 4 and 4 goes to 3, and that 1, 2 missing, so 1 goes to 2 this way. And we know that what is tau inverse? So tau inverse is, you just 1, 2, 3, 4. तो 1 की इमेज क्या है? तो यहाँ पर 1 किसकी इमेज है? 1 की, सो इट इज 1. 2 की इमेज क्या रहेगी टाउ इनवर्स में? तो 2 किसकी इमेज है? 2 की, सो इट इज 2. व्हाट इज द इमेज ऑफ 3 इन टाउ इनवर्स? सो you look in the tau. 3 is image of which object? That is 4. So it is 4. And what is the image of 4? तो 4 किसकी इमेज थी? 3 की. So this one is 3. Right. So what we get here? It is tau itself. So what? Is it happened with every permutation? Then answer is yes. Yes, it is happened. Right. So tau inverse is tau. So let us prove in general. Let tau is equal to AB belongs to, say, in Sn. Then you just find out tau into tau. So that is what? AB. Or you say, see, why AB? A1 and A2. Any object in Sn. So it is A1, A2, A1, A2. तो देखो यहाँ पे A3, A4 up to AN are invariant. Here also invariant. So you just find out product. Now we know how to find the product without expanding it. So it is A1. You start with A1. A1 goes to A2, and here A2 goes to A1. Now you start with A2. A2 goes to A1, and here A1 goes to A2. So stop. Now what about A3? A3 goes to A3, A3 goes to A3. A4 goes to A4, A4 goes to A4, and so on. Similarly, AN. So this is what? Identity, 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 identity. So no need to write n times identity. It's simply A1, and this is what? Identity. So what I get? Tau into tau is identity. तो इन दोनों का प्रोडक्ट आइडेंटिटी है, एंड यू कैन वेरीफाई इन दिस वे ऑल्सो. सो इट मीन्स व्हाट? टाउ इनवर्स इज टाउ. इन दोनों का प्रोडक्ट आइडेंटिटी, तो ये दोनों एक दूसरे के इनवर्स है, तो इसका इनवर्स उसके पास वाला, बट दैट इज व्हाट? इटसेल्फ. सो टाउ इनवर्स इज टाउ, एंड टाउ इज व्हाट? इट इज अ ट्रांसपोजिशन. तो यहाँ से क्या प्रूव हुआ? ट्रांसपोजिशंस आर सेल्फ इनवर्स. तो हमने आगे देखा था ग्रुप में कि ग्रुप में जो एलिमेंट वो खुद के इनवर्स है, दैट इज कॉल्ड सेल्फ इनवर्स एलिमेंट, और उसका ऑर्डर भी क्या हो जाता है? 2. यदि वो आइडेंटिटी नहीं है, देन इट्स ऑर्डर बिकम्स 2. जो खुद के इनवर्स है, आइडेंटिटी भी खुद का इनवर्स है, लेकिन उसका ऑर्डर 1 रहता है. लेकिन आइडेंटिटी के अलावा जो कोई एलिमेंट मुझे मिल रहा है कि जो खुद का इनवर्स है, तो उसका ऑर्डर हो जाता है 2. तो यहाँ हमने प्रूव कर दिया कि इन Sn transpositions are self inverse. So let us write now number 5. Transpositions are self inverse. And so the order of any transposition is always 2. ट्रांसपोजिशन का हमें ऑर्डर 2 ही मिलेगा, राइट? तो इसका हम क्या यूज कर सकते हैं? सी, ट्रांसपोजिशन वो खुद का इनवर्स है. सपोज मैं काम कर रहा हूं S7 में काम कर रहा हूं, राइट? एंड इफ आई हैव से यू कंसिडर टाउ, और टाउ के बदले में लेट मी यूज अल्फा. अल्फा इज 2 5. तो ये मेरा एक ट्रांसपोजिशन हो गया, साइकिल ऑफ लेंथ 2. तो जब मुझे आइडेंटिटी की जरूरत पड़ेगी देन आई कैन राइट 2 5 2 5, राइट? तो ये तो इसका ये इसका इनवर्स यही है itself. So product of these two will be what? It will be the identity. So I can write identity in this way, right? And you can verify also. You just compute it. You start with 2, 2 goes to 5, and here 5 goes to 2, stop. 5 goes to 2 and 2 goes to 5, stop. And the remaining objects in S7 unchanged by these 2. So 1 3 4 6 and 7 will be as it is, but all these are identities. So you can write it is this one, and this is what identity. So product is identity. So identity can be written in this way. So suppose I want to write identity in S7, then I can write in this way also. 1 2 1 2. This is my identity because it is a transposition. Product of 2 transposition is this is transposition. So product of transposition with itself will give me the identity. I can write in this way also 3 4 3 4. I can write it in this way 3 4 and 4 3. You write 3 4 or 4 3. You can always change the order of a cycle will remains unchanged by changing the order of elements in cyclic order. Image of 3 is 4 and image of 4 is 3. This transposition also gives the image of 4 is 3 and image of 3 is 4, right? So identity can be written in this way also. Okay, now this is what तो अभी हमने वो जो डिस्कस किया था कि जो मेरा कोई परम्यूटेशन है तो वो मुझे दिख रहा था कि इट इज अ प्रोडक्ट ऑफ साइकिल एंड दैट साइकिल्स आर डिसजॉइंट. सो कैन वी एक्सप्रेस एवरी परम्यूटेशन इन दिस वे? देन द आंसर इज यस. वी कैन ऑलवेज राइट एवरी परम्यूटेशन एज अ प्रोडक्ट ऑफ डिसजॉइंट साइकिल. वो कैसे लिखते हैं? सो लेट मी फर्स्ट ऑफ ऑल फ्रेम द स्टेटमेंट. विल नॉट प्रूव इट. प्रूफ आपको किसी भी टेक्स्ट में मिल जाएगी आपको, एंड इट रिक्वायर्स सम नोटेशंस एंड इट्स टाइम कंज्यूमिंग. प्रूफ इज वेरी इजी. एवरी परम्यूटेशन can be written as product of disjoint cycles, and this is very important phenomena in SN. So you consider say f is equal to 1 2 3 4 5 6 7 8. It is an element of S8. 1 2 3 4 5 6 7 8. Consider in this way, right? So I want to express this f as a product of disjoint cycle. So how can I express it? So you start with any object out of 1 to 8. So but for simplicity it is advisable you always start with 1, right? So 1, and 1 goes to 4, so you write down 4 here. Now 4 goes to 2, 2 goes to 3, and 3 goes to 1. So we arrived at the starting object, so we will not write, but we stop here. So 1 goes to 4, 4 goes to 2, 2 goes to 3, and 3 goes to 1. Now you consider the object from 1 to 8 which is not present in this cycle. So here we obtained one cycle. So what is the purpose of doing this? We are starting with the object which is not present here. So it means what? It will not if we start with the object which is not present here, then whatever the cycle becomes here, produced here, it will not contain any object which is present in the first one. As a result, we get these two cycles are disjoint. So here 1, 2, 3, 4 are present. So the next one is 5. So it is also not necessary that you start with 5 only. You can start with any object which is not present here. Here 5, 6, 7, 8 are not present here, but for the counting and for easy calculation you go in this order. So here 5 is absent, so you start with 5. So 5 goes to 7, 7 goes to 5. So stop. You always stop or you always terminate the cycle if you reach at a point of the starting. So 5 goes to 7, then 7 goes to 5, so stop. Now 1, 2, 3, 4, 5, 6 is not covered, so you start with 6. Here 6 goes to 6, so stop. Then 1, 2, 3, 4, 5, 6, 7, 8 is missing, so you start with 8, 8 goes to 8, so stop. So this is my f. This is my f. So product of this 1, 2, 3 and 4. So these 4 are cycles. First one is a 4 cycle, second is 2 cycle, third one is 1 cycle, and fourth one is 1 cycle. So if you find out the product of this 4 cycle, then you will get this one and you can verify it, right? So how can we verify it? See 1, 2, 3, 4, 5, 6, 7, 8. From here 1 goes to 4. Now you look at the image of this 4 in this cycle. 4 goes to 4. वो कहीं नहीं जाएगा क्योंकि यहाँ पर जो सिंबल है वो कहीं और नहीं आ रहा है, तो मतलब बाकी के सिंबल में वो चेंज नहीं, बाकी के साइकिल में वो चेंज नहीं होने वाला. सो 1 goes to 4 and 4 goes to 4, 4 goes to 4, 4 goes to 4, so 1 goes to 4. 2 goes to 3, 3 goes to 3, 3 goes to 3, 3 goes to 3, right? So sorry, 2 goes to 3, 3 here. 3 goes to 1, 1, 1, 1. 4 goes to 2, 2 goes to 2, 2 goes to 2, 2 goes to 2. 5 goes to, see here 5 is not here, so 5 goes to 5, here 5 goes to 7. 7 goes to 7, 7 goes to 7, so 7. Now 6, 6 goes to 6, 6 goes to 6, 6 goes to 6, 6 goes to 6, here 6 goes to 6. Now 7, 7 goes to 7, 7 goes to 5, 5 goes to 5, 5 goes to 5. And for 8, 8 goes to 8, 8 goes to 8, 8 goes to 8, and 8 goes to 8. So 4, 3, 1, 2, 7, 6, 5858. So product of this you will get the same thing. So it means these two things are equal, but this is what the F is product of cycle and cycles are disjoint. So in this way you can always write every permutation as a product of disjoint cycle, and this is very important thing. So let us consider one more example and try to write down a cycle in permutation as a product of disjoint cycles. So you consider F is equal to 1 2 3 4 5 6 7 8 and say 9 belongs to S9. 1 2 3 4 5 6 7 8 and say 9. You can start with any element, but it is advisable you always start with 1. Here 1 goes to 6, 1 goes to 6, then 6 goes to 1, so stop. Now 1 2 is missing, 2 goes to 7, 7 goes to 8, 8 goes to 5, 5 goes to 5. Why 5 2 times? So this is wrong, right? So see, let me 9 objects, right? So 1 2 3 4 is not there, so let me 4 is not there now, so let me consider this is 4. 1 2 3 4 5 6 7 8 and 9. Fine. Okay, so now let us start from the beginning. 1 goes to 6, 6 goes to 1, so stop. Now you start with 2. 2 goes to 7, 7 goes to 8, 8 goes to 4, 4 goes to 2, 2 goes to 7, 4 goes to 2, and here we have 2, so we stop here, right? So 1 2 3 is missing, so you start with 3. 3 goes to 3, stop. 1 2 3 4 5 is missing, 5 goes to 5, stop. Now 1 2 3 4 5 6, 6 goes to 1 and 1 goes to 6, stop. Now 7 is missing, 7, so 7 goes to 8, 8 goes to 4, 8 goes to 4, but why 4 is there? 4 is already here. Okay, sorry, 7 is already here, right? So no need, it is 1 2 3 4 5 6 7 8 and 9 is missing. Yes, so 9, and 9 goes to 9. So 1 3 5 6 9, these are one cycle, they represent the identity, so no need to write it is 2 7 8 4. So F is what? It is a product of only one cycle, or it is a cycle. In fact, F is a cycle, right? F is a cycle, or F is a product of 1 2 3 4 5 6 disjoint cycle. Among 5 are identity. Okay, so in this way you can always express any permutation as a product of disjoint cycle. Okay. नाउ हमने क्या किया, ये परम्यूटेशन था, तो परम्यूटेशन को हमने साइकिल में डिकम्पोज कर दिया. सी ऐसा ही क्या कहाँ पे हो रहा है हमारे पास. सपोज इफ आई हैव सम इंटीजर्स है 24. So 24 is what? 8 into 3. 8 is what? It is 2 cube into 3. So this 24 can be written as product of two integers, and there is nothing common between these two. Every integer can be written as product of integers, and in which any two integers are co-prime. ऐसे हम लिख ही सकते हैं, राइट. or further we can write 8 as 2 cube into 3. So that is what product of powers of prime. तो ऐसी ही चीज़ कुछ यहाँ पे हो रही है कि कोई भी मुझे परम्यूटेशन दिया है तो उसको मैं डिकम्पोज करने की ट्राई कर रहा हूँ, और डिकम्पोज इन व्हाट, इन द डिसजॉइंट साइकिल. अब मैंने ये साइकिल, चलो अब एक काम करते हैं, साइकिल लेते हो. साइकिल को कैन वी फर्दर डिकम्पोज इन सम अदर ऑब्जेक्ट्स. सो लेट अस ट्राई टू सी. सो यू कंसीडर से सिग्मा और से यू से अल्फा. अल्फा इज इक्वल टू 2 5 3 1 बिलोंग्स टू से S6. S6 में मैंने एक एलिमेंट लिया, एक साइकिल लिया. इट इज ऑफ लेंथ 4. ओके, नाउ लेट मी कंसीडर it is 2 1 sorry 2 5 2 3 and 2 1. You consider these 3 transpositions: cycle of length 2, cycle of length 2 and cycle of length 2. So now I want to find what is this, and we know how to find the product. So let us try to find out. This is what you can start with any object, and we are working in S6, so I have 6 objects, right? So you can start with any object. So let me start with 2. So 2, here 2 goes to 5, 5 goes to 5, 5 goes to 5, so 2 goes to 5. Now you look at the image of 5 in first cycle. It is 5 goes to 2, 2 goes to 3, 3 goes to 3, so 3. Now you look at the image of 3 in first cycle. 3 goes to 3, 3 goes to 2, and here 2 goes to 1, so 1. Now you look at the image of 1 here. 1 goes to 1, 1 goes to 1, and here 1 goes to 2, so 2. But 2 is what? 2 is the starting point, so we will not write 2. It is just this one, right? And what about the remaining 1 2 3 4? What about 4? But 4 is invariant, 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 so no need to write here 4. If you wish to write, then you can write 4. 4 goes to 4, 4 goes to 4, 4 goes to 4. 5 आ गया. अब 6, 6 goes to 6, 6 goes to 6, 6 goes to 6. But this represents the identity, so no need to write this one. So it is simply this one. But this is what my alpha, right? This is my alpha. So what does it mean? So I can write this thing. This one is this one, and it is what? 2 5 2 3 2 1. तो ये मैंने कैसे लिखा? 2 को फिक्स किया, इसकी पेयर बनाई 2 5 उसके पास वाला, then 2 with 3, then 2 with 1. So this is a trick, right? So what I have, suppose I have say beta is equal to 5 3 1 7 2 9 8 belongs to से S9. S9 का मैंने कोई ऐसा साइकिल ले लिया, 1 2 3 4 5 6 7 साइकिल इन S9. And suppose I want to write as a product of transposition, then what is the way? You fix 5 को fix कर दो. 5 with 3, you consider a transposition in this way, 5 3, then 5 1, then 5 7, 5 2, then 5 9, then 5 8, right? So this is what beta, product of transpositions. These transpositions are not disjoint. See, these are not, because 5 occurs in every transposition, right? But what we can do, any cycle can be written as product of transposition. Okay, तो अब मैं क्या करता हूँ, सी ये जो मेरा 5 3 और ये 5 1 5 1 5 7 5 2 5 9 and 5 8, correct? between phi 3 and phi 1 I am writing 4 2. Why 4 2? Let me write here identity element of S9. So this is what, all these are elements of S9 and here identity. So this one into identity will be the same one, so I can write in this way. See, in group, suppose I have A B C D, some, then I can write A into E into B into C into D. E is identity, so I have just insert identity, but I know identity can be written as what, 2 3 2 3 2 3 2 3. So it is what, 2 3 is a transposition, so it is self inverse. So 2 3 into 2 3 is what, it is identity. So again, see, this format does not contain this transposition 2 3, but this product contains the transposition 2 3, and again it is a product of transposition. So these are two different forms, but they are product of transposition. So beta can be written as product of transposition in this way as well as this way. Then let me insert phi 3 2 3 2 3 phi 1, then here 4 7 4 7 2 times. 4 7 is not here, but I have written 4 7 4 7, but meaning of 4 7 4 7 is identity. Then phi 7 phi 2 phi 9 and phi 8. So wherever I want, I will insert two transposition to same transposition. So the meaning of two same transposition is identity, so I can insert it. So beta can be written in this way also. Suppose if I insert some transformation once again here, product of two transposition here, so it is the another form. So in short, what, any cycle can be written as product of transpositions in infinitely many way, right? और आप इसको ऐसे भी लिख सकते थे, ये जो है उसका ऑर्डर चेंज करो, ये 3 को पहले ले जाओ, 3 1 7 2 9 8 5, and then you prepare. See, you can do in this way also. What I want to mean, see, this beta is what, it is 3 1 7 2 9 8 5 also. ये 3 को मैंने शिफ्ट किया, and now you compute in this way, write beta in this way, 3 1 3 7 3 2 3 9 3 8 and 3 5. 3 की पेयर बनाओ, ये दोनों तो सेम है, and I can write this in this way also. So these two are equal. So again beta is what, it is a product of transposition. Again you do the same technique here, you insert identity here and you write down identity as a product of transposition. You write down the one transformation 2 times. So again you have this expression, gives you infinitely many expression other. So in short, any any cycle can be written as product of transpositions in infinitely many ways. So हमारा next result बनता है 7th, every cycle can be written as product of transpositions in infinitely many ways. इसको आप infinitely many ways से लिख सकते हैं. ओके, तो हमने क्या किया कि मेरे पास पहले एक परम्यूटेशन था, परम्यूटेशन को मैं डिसजॉइंट साइकिल्स के प्रोडक्ट में लिख सकता हूँ. आई कैन राइट एवरी परम्यूटेशन इज अ प्रोडक्ट ऑफ डिसजॉइंट साइकिल. अब साइकिल को ब्रेक किया ट्रांसपोजिशन में, मतलब मैं उसकी जो लेंथ है वो कम करता जा रहा हूँ. सो अल्टीमेटली व्हाट आई हैव, इफ यू कंबाइन दिस टू रिजल्ट्स 6 and 7, एवरी परम्यूटेशन कैन बी रिटन एज प्रोडक्ट ऑफ डिसजॉइंट साइकिल। अब ये हर एक साइकिल को आप डिकम्पोज करिए ट्रांसपोजिशन में, एंड वी कैन डिकम्पोज द साइकिल इनटू ट्रांसपोजिशन इन इनफाइनेटली मेनी वे। सो अल्टीमेटली एवरी परम्यूटेशन कैन बी रिटन एज प्रोडक्ट ऑफ ट्रांसपोजिशन इन इनफाइनेटली मेनी वे, राइट। सो हमारा नेक्स्ट रिजल्ट बनता है 8, एवरी परम्यूटेशन can be written as product of transpositions in infinitely many ways। एक एग्जांपल देख लेते हैं। See, for example, you consider, say, alpha is equal to 1 2 3 4 5 6 7 8 belongs to S8, 1 2 3 6 1 2 3 4 5 6 7 and 8. Okay, so now this alpha is what? It is a permutation, S8. I don't know whether it is a cycle or not, I don't know, but let us write down. It can be written as product of disjoint cycle. So let us start with 1 goes to 6, then 6 goes to 3 and 3 goes to 1. So stop. Now you start with any symbol which is not here, so 2 is not here, so 2 goes to 4, 4 goes to 2, stop. Now 1 2 3 4 5 is not here, so 5 goes to 7, 7 goes to 5, 1 2 3 4 5 6 7 and 8 is missing, so 8 goes to 8. So now every symbol is covered. But this is what? Product of डिसजॉइंट साइकिल। इस साइकिल में जो सिंबल है वो यहाँ पर नहीं है, यहाँ पर है, वो यहाँ पर नहीं है, कोई मतलब दे आर म्यूचुअली डिसजॉइंट साइकिल। नाउ दिस टू आर ट्रांसपोजिशन and this one is identity. So first of all, no need to write this 8, so it is 1 6 3 2 4 5 7. No need to write it because it represents the identity. Now 1 6 3 can be written as 1 6 and 1 3, 1 6 1 3, and this 2 4 5 7. तो क्या हुआ? Alpha is a product of disjoint cycles, and here alpha is a product of transpositions. So every permutation can be written as a product of transpositions in infinitely many ways. You can insert identity, or you can write, say, this is 1 6 2 7 2 7 1 3 2 4 5 7. तो मैंने ये insert कर दिया. Now you can insert this type of pair of transposition anywhere, wherever you want. So we have infinitely many way. So I hope this thing is clear. So this is what result number 8. So from here, see, now what we have, every permutation can be written as product of transposition. मतलब कोई भी permutation उठाया वो ट्रांसपोजिशन का प्रोडक्ट है. तो देखिए, ये हमने पहले अल्फा लिया था, तो ये फर्स्ट वी कैन राइट इन दिस वे. सो इट इज अ प्रोडक्ट ऑफ 1 2 3 4 ट्रांसपोजिशन. अब हमने ये इंसर्ट किया 2 7 2 7, तो यहाँ पर वो अल्फा क्या था? पहले 5 ट्रांसपोजिशन का प्रोडक्ट था. अब ये जो फॉर्मेट है वो हमें दिखा रहा है कि इट इज़ अ प्रोडक्ट ऑफ 1 2 3 4. वाई इट इज़ 1 2 3 4, सॉरी 4 ट्रांसपोजिशन का प्रोडक्ट है ना, 4. अब ये 4 तो आ ही रहे हैं और 2 हमने ऐड कर दिए, तो 4 + 2, तो मतलब इस फॉर्मेट में वो 6 ट्रांसपोजिशन का प्रोडक्ट है। यदि मुझे और फॉर्म लेना है देन आई हैव टू इंसर्ट 2 ट्रांसपोजिशंस एट ए टाइम, so it becomes 6 plus 2, that is 8. Another form, then 8 plus 2, 10. So every time alpha will be the product of either 4 transposition or 6 or 8 or 10 or 12 and so on. But all these 6, 4, 6, 8, 10, 12, all these are what? Even numbers. तो कभी आप अल्फा को प्रोडक्ट ऑफ ट्रांसपोजिशन लिख रहे हैं तो कोई ऐसा फॉर्मेट आपको नहीं मिलेगा कि जिसमें वो ओड नंबर ऑफ ट्रांसपोजिशन का प्रोडक्ट हो, क्योंकि ये लिस्ट फॉर्म है मेरा। आई रिक्वायर्ड दिस मिनिमम नंबर ऑफ ट्रांसपोजिशन, और अब मुझे उसका अलग फॉर्म लेना है, देन आई हैव टू इंसर्ट 2 ट्रांसपोजिशन एट ए टाइम। सो दीज आर इवन नंबर, सो इवन प्लस 2 इज ऑलवेज इवन। तो यहाँ से क्या हुआ कि अल्फा को मैं जब भी लिखूंगा प्रोडक्ट ऑफ ट्रांसपोजिशन, आई रिक्वायर्ड ऑलवेज इवन नंबर ऑफ ट्रांसपोजिशन। और कोई मेरे पास ऐसा भी परम्यूटेशन मिलेगा कि जिसको मुझे लिखने के लिए यहाँ पे मुझे 4 की ज़रूरत पड़ी, तो हो सकता है कि वहाँ पे मुझे 7 ट्रांसपोजिशन की ज़रूरत पड़े। देन इफ़ आई ट्राई टू राइट डाउन दैट परम्यूटेशन एज अ प्रोडक्ट ऑफ ट्रांसपोजिशन, देन आई रिक्वायर्ड 7, देन 9, देन 11 एंड सो ऑन। तो एक बार मैं किसी परम्यूटेशन को प्रोडक्ट ऑफ ट्रांसपोजिशन में लिखता हूँ, उसके लिए मुझे ऑड नंबर ऑफ ट्रांसपोजिशन चाहिए, तो उसके किसी भी फॉर्मेट में ऑड नंबर ऑफ ट्रांसपोजिशन ही चाहिए। सो दिस थिंग्स गिव्स मी मोटिवेशन टू डिफाइन अ न्यू टर्म, दैट इज इवन permutation and odd permutation. So let us define. So this is our next definition. A permutation F belongs to Sn is called, first, an even permutation if F can be written as product of even number of transpositions, even number of transpositions. And the second thing, a permutation F belongs to Sn is called an odd permutation if F can be written as product of odd number of transpositions. मतलब मुझे कोई परम्यूटेशन दे दिया है तो उसको मैं इवन वो परम्यूटेशन है या ऑड परम्यूटेशन है वो कैसे डिस्टिंग्विश करूँगा? आई विल राइट दैट permutation as a product of transposition and we know how to write it. Then you count how many transformations are required to represent that permutation. If that number of transposition is even, then I will say my permutation is even permutation, and if number of transpositions required to present permutation is odd, then I will say it is my odd permutation. So I hope this is clear. So in the previous example we required 4 transpositions, so it is even permutation. Okay. और कोई भी परम्यूटेशन है ना मेरा, वो दोनों नहीं हो सकता कि इट इज ऑड परम्यूटेशन एज वेल एज इवन परम्यूटेशन, ऐसा नहीं हो सकता. इट इज ऑलवेज आइदर इवन और ऑड. कोई ऐसा भी नहीं हो सकता कि ये ऑड भी नहीं है इवन भी नहीं, क्योंकि एवरी परम्यूटेशन कैन बी रिटन एज प्रोडक्ट ऑफ ट्रांसपोजिशन. तो वो जो प्रोडक्ट ऑफ ट्रांसपोजिशन आ गया, देन एक बार मिल गया तो आप उसको काउंट कर लो कितने ट्रांसफॉर्मेशंस है उसमें, ट्रांसपोजिशंस है. यदि वो ऑड है तो उसके हर एक रिप्रेजेंटेशन में ऑड ही रहेंगे. यस, वो नंबर बदल सकता है लेकिन वो नंबर इवन नहीं हो सकता. ऑड के लिए ऑड ही रहेगा, इवन के लिए इवन ही रहेगा. राइट. So this is what definition. So then we have some again results and property with respect to even permutation and odd permutation. So let us see results and properties next. So first, a permutation cannot be both even and odd. वो दोनों नहीं हो सकता, either it is even or odd. यदि वो even है या odd है. तो देखिए हमारे पास जो एक वो हमने टेक्निक यूज़ की थी साइकिल में कि मेरे पास कोई साइकिल है तो देन दैट साइकिल कैन बी रिटन एज अ प्रोडक्ट ऑफ ट्रांसपोजिशन. तो वो कैसे हमने किया था. सो लेट अस वंस अगेन विजिट इट. सपोज अल्फा इज इक्वल टू 57293. इट इज़ सम एलिमेंट ऑफ से S10 का एक साइकिल ले लिया. तो दैट आई कैन राइट दिस इज व्हाट 5752. You consider the pair like this 52, then 59 and then 53. ऐसा pair consider करो. So alpha is what? It is a cycle and it is a product of transposition. Alpha is a cycle of length 5. Alpha is what? It is a 5 cycle. And alpha is what? It is a product of 4 transposition. And 5 is what? It is 5 minus 1. तो ऑब्वियसली हमने 5 को फिक्स किया और ये 5 के साथ हर एक की पेयर बनाई. मतलब मेरे पास सपोज n है, n लेंथ का साइकिल है. सपोज आई हैव अ साइकिल ऑफ लेंथ n. तो उसमें से मैं एक को फिक्स करूँगा और बाकी के हर एक के साथ मैं उसकी पेयर बनाऊँगा. And that pair gives me a transposition, and as a result I have a cycle of length n is a product of n minus 1 transposition. So from this observation I can write this: a cycle of length n can be written as product of n minus 1 transpositions. राइट, n minus 1 ट्रांसपोजिशंस. तो देखो ये जो अल्फा एक मेरा साइकिल है तो वो अपने आप में एक परम्यूटेशन तो है ही. राइट, तो ये जो अल्फा की लेंथ क्या थी यहाँ पर 5 थी, लेकिन वो प्रोडक्ट ऑफ ट्रांसपोजिशन कितने ट्रांसपोजिशन का प्रोडक्ट है 4. 4 इज 5 माइनस 1. तो ये मेरा 5 ओड है, लेकिन उसको मैं ये जो 4 है 5 माइनस 1 दैट इज इवन. तो ये मेरा जो अल्फा साइकिल था वो क्या हो गया, इट इज़ इवन परम्यूटेशन. उसकी लेंथ ओड है लेकिन वो परम्यूटेशन इवन है. ऐसा भी हो सकता था से बीटा इज से 73295 अगेन इट इज एलिमेंट ऑफ S10. सो इट इज ऑल्सो साइकिल ऑफ लेंथ 1 2 3 4 5 6 लेंथ का साइकिल है. लेकिन आई कैन राइट बीटा एज 73 72 79 75 74 1 2 3 4 1 2 3 4 5. तो इट इज अ प्रोडक्ट ऑफ 5 ट्रांसपोजिशन. तो बीटा क्या हो गया, ओड परम्यूटेशन, और यहाँ पे अल्फा इवन परम्यूटेशन. तो उसकी लेंथ ओड है लेकिन परम्यूटेशन इवन है. यहाँ पर लेंथ इवन है लेकिन परम्यूटेशन ओड है. सो वी कैन हैव दिस रिजल्ट. द थर्ड वन, अ साइकिल ऑफ लेंथ n is even permutation if n is साइकिल को इवन परम्यूटेशन बनना है तो उसकी लेंथ को ऑड होना पड़ेगा। ये मेरा इवन है तो उसकी लेंथ ऑड है, और ये मेरा ऑड है तो उसकी लेंथ इवन है। सो ऑपोजिट है। सो साइकिल ऑफ लेंथ n इज इवन परम्यूटेशन इफ n इज ऑड। और फोर्थ वन, a cycle of length n is odd permutation if n is even। मतलब इवन लेंथ का साइकिल ऑड परम्यूटेशन है और ऑड लेंथ का साइकिल इवन परम्यूटेशन है। दिस इज वेरी सिंपल ऑब्जर्वेशन बट इट विल बी क्वाइट हेल्पफुल व्हेन वी डू कैलकुलेशंस इन SN। okay, so this is the result number 4. now there is a natural question, what about the identity? ये जो हमारा आइडेंटिटी है वो इवन परम्यूटेशन है या ऑड परम्यूटेशन है? सी आइडेंटिटी क्या है? व्हाट इज आइडेंटिटी इन SN? ये मैं कोई भी SN ले लेते, S5 S10 वॉट एवर। सो आइडेंटिटी कैन बी रिटन इन दिस वे, दिस इज माई आइडेंटिटी, यू कैन राइट 2 ऑल्सो 3 ऑल्सो वॉट एवर, बट see now I will write this 1 can be written as 1, now 2 3 2 3, let me write in this way. So again this is identity, identity into identity is identity. So this is what, now this represents identity, so I will not write 1, I will write just 2 3 2 3. So what I have, identity is a product of two transposition and 2 is even, so I is what, even permutation, right? And suppose I want, if I want to write I in the another way of product of transposition, then I have to insert 2 transposition at a time. So 2 plus 2 is 4, 4 plus 2 is 6, and so on. So 5, result number 5, the identity is even permutation. The identity is even permutation. Okay. Now it will be interesting to observe if you have two permutations, then we have 4 cases, both are even, both are odd, one is even, odd, odd, even, right? So if you have given 2 permutations, one is even, odd, then what will be the product, whether it is even or odd? If you are both the permutations are odd, then what can you say about its product? So say you consider say alpha and beta belongs to SN, ये 2 permutation ले लो आप। Suppose alpha is even and beta is odd, मान लो कि अल्फा इवन परम्यूटेशन है और बीटा ऑड परम्यूटेशन है, तो क्या होगा? अल्फा इज व्हाट, अल्फा कैन बी रिटन एज प्रोडक्ट ऑफ ट्रांसपोजिशन and the number of required transpositions are even by definition. So let alpha is equal to tau 1 tau 2 up to tau r. So where alpha is even, so and the here tau i's are what, here tau i's and these are transpositions. So alpha is a product of transposition and it is even, so this r will be what, it is even integer. Now beta is what, odd permutation, so beta can be written as mu1 mu2 up to mu s, where mu i's are transpositions and this s will be odd integer. Let me write here r is r even integer and this is odd integer, right? Now I want to find alpha beta. So alpha into beta is what, it is tau 1 tau 2 up to tau r. Alpha is tau 1, tau 2 up to tau r, and beta is mu 1, mu 2 up to mu s. Mu 1, mu 2 up to mu s. So alpha into beta is what? It is a product of alpha into beta is product of r transposition, and these are s transposition. So r plus s transpositions, right? Now my r is what? This is even, and s is what? This is odd, and both are integer. So even integer plus odd integer is what? It is odd integer. So what we have proved? Alpha into beta is a product of odd number of transposition. So alpha into beta is odd transposition. तो क्या प्रूव हुआ कि यदि मेरे पास दो परम्यूटेशन है SN में, one is even permutation and another is odd permutation, then its product is odd permutation. और बीटा अल्फा करता तो मतलब odd into even करता, then again odd plus even, again odd. So if you have two two permutations of different nature, one is even odd or odd even, then its product is odd, right? So we can here 6, then 7. Result number 7. Product of uneven and unodd, or let me write in bracket, or unodd and uneven permutation is an odd permutation. एक इवन और ऑड है, दूसरा ऑड और इवन है, देन इट्स प्रोडक्ट इज ऑड परम्यूटेशन. ओके, नाउ मान लो कि दोनों इवन है, अल्फा बीटा एसएन में और अल्फा इवन है और बीटा भी क्या है मेरा इवन है. देन अल्फा इज रिटन इन दिस वे, बीटा इज रिटन इन दिस वे, वेयर tau I and mu i's are transposition. Alpha is even, so this r will be even, and beta is even, so now this s will be also even. So alpha into beta is this one. So alpha into beta is a product of r plus s transposition. R is even and s is also even. So even plus even is, this is even. तो क्या हुआ, रिजल्ट बना हमारा 8. प्रोडक्ट ऑफ टू even permutations is an even permutation. And similarly you can prove product of two odd permutations is an even. वो भी even ही रहेगा. even permutation कैसे, मान लो कि अल्फा और बीटा दोनों odd है. So alpha is product of tau i's, beta is product of mu i's. Tau i's and mu i's are transpositions, and r will be odd because alpha is odd, and s will be also odd. And here we have alpha into beta is a product of r plus s transpositions, and both are odd. So odd integer plus odd integer is even integer, so it is even transposition. तो क्या हुआ, मतलब ये जो प्रोडक्ट है हमारा ट्रांसपोजिशंस का, सॉरी परम्यूटेशंस का, वेदर इट इज़ इवन और ऑड, तो वो उसका जो प्रोडक्ट है वो हमें कैसा मिलेगा, दैट डिपेंड्स जस्ट ऑन द सम ऑफ टू ऑड इंटीजर इज इवन, सम ऑफ टू इंटीजर इवन इंटीजर इज इवन, एंड सम ऑफ टू ऑड, वन ऑड and one even integer is odd. So it depends on that one. So but it is quite obvious. So these are what some results about the nature of the permutation, even odd, then what about the nature of the product of permutation? Okay, so now next natural question is what? Suppose I have given one permutation, then it will be either odd or even, but what about its inverse? Inverse is also a permutation. तो मुझे कोई permutation दिया है तो वो odd permutation है, तो उसका inverse क्या कैसा रहेगा? वो even हो जाएगा या odd हो जाएगा? So let us see. So let me deal with only one. So let alpha belongs to Sn and मान लो कि alpha मेरा odd permutation है, right? Alpha is odd permutation. So alpha is what? Alpha can be written as product of tau 1, tau 2 up to tau r. Tau is a transposition and r will be what? R will be odd. Now I want to find alpha inverse. So what will be alpha inverse? Alpha inverse will be what? It is tau 1, tau 2 up to tau r and its inverse, and not that. Here r is what? R is odd integer. ओके तो ये टाउ 1 टाउ 2 अप टू टाउ आर वो क्या है? वो भी एसएन के एलिमेंट्स ही है, वो ट्रांसपोजिशंस है। और हमने ग्रुप में देखा था, कोई भी ग्रुप ले लो, उसमें सपोज आई हैव A1 A2 अप टू AK एंड इट्स इनवर्स, देन बाय सॉक्स प्रॉपर्टी इट इज व्हाट? AK इनवर्स, AK माइनस 1 इनवर्स एंड सो ऑन, A2 इनवर्स, A1 इनवर्स। इनवर्स है वो रिवर्स में से अप्लाई होगा, तो यहाँ पर क्या होगा? टाउ आर इनवर्स इंटू टाउ r minus 1 inverse and so on, tau 2 inverse into tau 1 inverse, right? But we know that हमने वो कुछ रिजल्ट लिखा था आगे कुछ कि मेरे पास यदि ट्रांसपोजिशन है देन दे आर सेल्फ इनवर्स, मतलब टाउ इज टाउ 1 इज ट्रांसपोजिशन, सो टाउ 1 इनवर्स इज टाउ 1. So similarly tau r minus 1, tau 2, tau 1 all are transposition, so they are self inverse, so it is tau r minus 1 and so on, tau 2 and tau 1. So again alpha inverse is a product of 1 2 3 up to r transpositions, and r is what? R is odd, so alpha inverse is odd odd permutation. Similarly if r was even, then alpha is, if r was even, then अल्फा इज इवन परम्यूटेशन, एंड अल्फा इनवर्स को रिप्रेजेंट करने के लिए भी मुझे यही चाहिए, सो अल्फा इनवर्स इज इवन. तो यहाँ से क्या प्रूव होता है कि इनवर्स ऑफ इवन परम्यूटेशन इज इवन परम्यूटेशन एंड इनवर्स ऑफ ऑड परम्यूटेशन इज ऑड परम्यूटेशन. सो लेट अस राइट डाउन 10th. द इनवर्स of an odd permutation is an odd permutation, and 11th, the inverse of an even permutation is an even permutation. तो ऑड परम्यूटेशन का इनवर्स ऑड रहेगा, इवन परम्यूटेशन का इनवर्स इवन रहेगा. Okay, so this is what about the some results based on the nature of the permutation, whether it is even permutation or odd permutation. और एक छोटी सी एक टर्मिनोलॉजी है अगेन रिगार्डिंग दिस इवन परम्यूटेशन एंड ऑड परम्यूटेशन. सो लेट अस क्विकली सी एंड वी डिफाइन इट. signature of the permutation. What is signature of the permutation? Next we define definition. Let f belongs to Sn. Let f belongs to Sn, be product of R transpositions. तो कोई भी परम्यूटेशन है, then I can express as a product of transposition that we have seen, right? So I start with a permutation and suppose F is a product of R transpositions. Now what is R? Even or odd? That I don't know. It may be even, it may be odd, right? It may be even, it may be odd. It depends on F. If my F is even permutation, then R is even. And if F is odd permutation, then R will be odd. Then the signature of F is denoted by SIG, signature SGN, signature of F, and defined as SGNF is equal to -1 to the power R. And what is R? R is the number of transpositions required to express F as a product of transposition. So -1 raised to R. So obviously this if R is even, then this quantity is +1, and R is odd, then this quantity is what? -1, right? So immediately we have these two results, or you may say it is a remark. Let F belongs to Sn, then F is uneven. F is even. Even permutation implies signature of F is 1, and if signature of F is 1, तो ये 1 कब रहेगा? जब ये R even होगा तो, और R even है, but F R is what? Number of transpositions required to express F, so it is even, so F is even permutation. And similarly F is odd permutation if and only if signature of F is -1. So this is one terminology regarding परम्यूटेशन. ये हम किसी और तरीके से भी डिफाइन कर सकते हैं, वो बाद में देखेंगे, लेकिन दिस इज़ द सिंपलेस्ट वे टू डिफाइन द सिग्नेचर. लेकिन सिग्नेचर ऐसे नहीं, वो किसी और तरीके से भी डिफाइन करते हैं. दैट इज़ हेल्पफुल फॉर द अनदर टाइप ऑफ थियरी. इफ टाइम परमिट्स, देन वी विल ऑल्सो सी द अनदर वे टू डिफाइनिंग दिस सिग्नेचर, and we get the same thing, right? But for problem solving we just use this shortcut. Okay, so this is what about the SN. और भी अभी हमें SN में थोड़ा स्टडी करना है. The next thing we will discuss in the next lecture about SN, and right now we stop this lecture here. Thank you.